Hello everyone and welcome to this latest webinar from the World Broadband Association, co-sponsored by Omdia. My name is Michael Philpott and I'm the Research Director for Service Provider Consumer at Omdia. And today's topic is Unlocking the Future, how the Metaverse and XR will drive the evolution of broadband networks. Thank you everyone for joining us today. Before we begin, I just want to cover a few basic housekeeping items. At the bottom of your audience console, there are multiple application widgets which you can use. Make sure that you check these out during the webinar. A copy of today's slide deck and other valuable resources are available to download in the resource list widget. If you have any questions during the webinar, you can submit these through the Q&A widget located on the left-hand side of your screen. All questions will be captured. So if we don't get to answer you today, we may follow up by email. An on-demand version of the webinar will be available in approximately 24 hours and can be accessed using the same audience link that was sent to you earlier. Finally, if you have any technical difficulties, just click on the help widget where you can find answer to some common questions. Now, let me introduce you to the panel. Today, we are joined by Dr. Marcus Brunner, Working Group Chair of the World Broadband Association and Chief Expert for Enhanced Broadband at Huawei Technologies Switzerland. Dr. Omar Alumi, Working Group Chair of Network Requirements and Capabilities at the Metaverse Standards Forum and Distinguished Member of the Technical Staff at Nokia. And then finally, Kevin Hasdy, the VP of Strategic Initiatives at Ookla. Welcome all to the panel. Now, let's get started with the presentation. Before we move on to the main presentations today, I just wanted to give a brief introduction to the topic of the webinar. Of course, broadband networks have evolved significantly since they were first launched, moving through these basic generations, which have been broadly defined by access technology, moving from ADSL, basic ADSL technology in the early days, delivering speeds of typically 500 kilobits per second to 30 megabits per second, through to fiber to the cabinet type networks, and then finally through to all optical fiber to the home networks that we have today, delivering hundreds of megabits per second down to homes, if not multiple gigabits per second in many countries. However, these kind of broad generations have never really been formalized, certainly not been standardized, and therefore different countries have taken different routes through their development and certainly developed at very different speeds. You can see from the chart on the right that if we look at what I consider to be perhaps a basic broadband service of 30 megabits per second, and certainly Omar is going to talk about that 30 megabits per second is kind of the base level of service that you need for XR applications today. And you can see that even by 2030, in Omdia's forecast of the top 67 countries, that in 27% of countries, the broadband penetration of at least 30 megabits per second is less than 50%. In fact, in some countries, as you can see, it is far less than that. If you then shift to 100 megabits per second, which is required for more advanced applications, then you can see that that ratio shifts now to 35% of countries. And then if you shift even further to 1 gigabits per second, what is some kind of becoming the standard service in some countries today, you can see that's kind of 90% of cases where it'd be 50% penetration or less by 2030. And this, of course, is just subscription speeds. In Kevin's presentation later, he's going to talk a little bit about the difference between subscription speed that the consumers are paying for and the actual experience that they're receiving on their end devices. And that's important because, of course, next generation internet applications will have higher and higher requirements on the broadband networks, none more so than XR and AI technologies. And Omar, in his presentation, is going to talk a little bit more about that. Consumer XR, of course, is still very much in its infancy, but we predict that with more affordable devices and a better availability of more attractive content, then that penetration will start to gradually pick up 2024 and onwards. And that's important because of the scale of the consumer market, then that drives innovation, which then can be used in the enterprise in the enterprise market, where we see much easier to understand use cases, and we see already demand well underway. In Omdia's surveys, 9 out of 10 enterprises can now identify a compelling use case for XR technology, and almost a fifth of them are already starting to invest in it. The risk is, though, of course, is that those countries that have already a well-developed and highly advanced broadband networks will be able to take advantage of all that new innovation and technology, which will then drive greater efficiencies in the enterprise space and more innovation, and therefore driving social economic development. Unfortunately, those countries that are still emerging are less so, and therefore the risk of being left further and further behind. And that's why the World Broadband Association developed its roadmap, not just to formalize those broadband generations as we go forward, but also so that countries can kind of measure where they are on that roadmap, and therefore easier to set out their own plans for future development. Of course, though, it's important for the organization to continue to analyze that roadmap, make sure it's still up to date and still fit for purpose. And that's why it's important to measure this roadmap with the roadmap of other applications and other services. And that's why the World Broadband Association set out this research to work with the Metaverse Standards Forum in doing that. And with that, I'd like to hand over to our first speaker today, Omar, who's going to look at the Metaverse applications from the MSF perspective. Thank you, Omar. Over.
Thank you. Thank you very much. I hope you can hear me.
Yes, we can. Yeah.
Yeah, so today I'm speaking on behalf of the Metaverse Standards Forum. So the Metaverse Standards Forum is looking holistically at Metaverse application and XR applications. And what we try to do is we try to create the condition for interoperability to happen at scale within the Metaverse. Metaverse is complex. It has device dimension. It has network, infrastructure, cloud, core technologies like codecs and representation of data formats. There are services and also platforms. And the Metaverse Standards Forum is not, despite its name, is not working on standards and interoperability. Instead, we try to work with all those organizations to make sure we create the conditions for Metaverse to happen at scale. We do this through working on use cases and requirements, and we try to work with the other organizations. Today, for the purpose of this particular presentation, I will focus on network requirements. What we have been doing in the Metaverse Standards Forum, we started with a set of use cases, and we try to understand what it means in terms of network requirements so that we can analyze if current ongoing standards and technology can support Metaverse application at scale. This is providing some of the use cases we have been working on. We try to select a representative set of use cases from the consumer, enterprise, and industrial metaverse. You have few examples here. For instance, one at the top right is about wiring a street cabinet, where the user has an augmented reality equipment, which provides him with more information about how he can do the wiring. We have another example of immersive telepresence. We can have another example about local interaction assisted by offloaded processing, which is the ability of sending video streams and getting more information in an augmented reality manner. Now, when we analyzed the use cases, we came across one important thing, which is the starting point for our network requirement will be the need to have a look a little bit more into the architecture, because if you think about the delay, we try to come up with a delay budget, which is the end-to-end delay between one application or another application, or between a sensor and a screen, or between a camera and a screen. And only by looking at the different components of the architecture, you can derive the network requirement, because you start with the end-to-end delay and you subtract the delay needed for different components for their own processing. In this particular example, it's about remote control of an AGV or of a car. And what you see at the top right is the AGV or the car. It's equipped with sensors, with cameras, and it can accept controls. The sensors will send information which will be translated into haptics that can be used by the person who is steering the car. You have also the cameras, which is sending video traffic upstream, and the video could be encoded by a media server and decoded at the device side at the side where the person is controlling this. When we look at the delay, we try to figure out the delay end to end, and we try to reduce the amount of delay which is needed for at the network side. The same thing happens for the throughput. We try to figure out the throughput requirements of the different flows, and this is the source of our own requirements. Therefore, by having a look at the different use cases in the top-down manner, we came up with a certain number of conclusions. So one of them is about latency. We concluded that the network delay budget for should be should be around 30 milliseconds for most demanding applications. But in general, most applications would live with a network delay of around 20 to 25 milliseconds. It will be satisfactory for the use cases. Throughputs, we distinguish between uplink and downlink. So for the downlink, most demanding application will require 80 megabits per second. And you can see that it's challenging. But most applications will live with 30 megabits per second. On the uplink, it's 30 megabits for most challenging application and 10 megabits per second for most applications. Surprisingly enough, in our analysis, we didn't come across use cases where jitter will matter for the application. This is under the assumption that the delay is kept low enough. Now we look at performance figures, but we also consider things like slicing and APIs. You have heard eventually about this Camera project, where we believe that the future is about establishing a link between the application and the network, and this is an important condition for metaverse application to be deployed at scale. We have been looking at different network technologies, and because we have limited times, I cannot go through all of them, but we have considered cable and 5G and Wi-Fi and PON and DSL. All of them, they have been considered. Some of our conclusions are the following. So if we consider 5G, we have concluded that in general, all the requirements are achievable by 5G. The issue is if you start deploying metaverse application at scale, it could be challenging. But we are also aware that there are ongoing standards activity in the context of 5G advanced standards that are aiming to solve those issues. For passive optical networks, the conclusion is very clear. Technology are capable today of addressing metaverse requirement, both as a backhaul solution or access network. In an end-to-end solution coupled with another access network like Wi-Fi, or at least the early version of Wi-Fi, the latter could be a bottleneck. And we came across conclusion that technology like IETF L4S, which stands for low latency, low loss, and scalable throughput, could support bringing the latency down to acceptable level, assuming that the application can adapt to feedback from the network. More of those conclusions are available in our deliverables, and they are available on the Metaverse Standards Forum website. Then this is the theoretical part of the exercise. And actually, we have access to UCLA data sets measuring performance over the internet for both fixed and mobile. So we have been looking at different geographies, Europe, Americas, and Asia. And we have observed that things are improving or going in the right direction. So for instance, if you look at those numbers, we have concluded that today's internet, on average, not under load conditions, has improved to deliver acceptable performance level to several metaverse applications. There remains disparities that exist among the different geographies. However, when filtering out the data to loaded network conditions, so under overload, it appears that both fixed and mobile networks provide too high latency to support metaverse application at scale. The other factor that we found dramatically impacts the performance will be the proximity to data centers. It may appear, so one of our conclusions, densification of the cloud will be super important because there is the network dimension, but there is the proximity to the cloud, which matters the most. Now, so then the question, is the internet ready to support metaverse application at scale? In terms of round-trip latency for wireline and wireless access, we have seen that the latency has been improving over time, and they are reaching acceptable level for the identified application needs. Now, of course, if you will deploy more high definition and 3D volumetric video, there might be further challenges. We think that there are disparities that exist across geographies, and the distance from the server, the population density, and deployed technology are the other factors that affect this latency parameter. The uplink capacity is extremely important. We have seen improvements from 4G to 5G. But in 4G deployments, we have seen that the uplink capacity could be a limiting factor for some of the most demanding applications. Then we have been looking at traffic management, for instance, this L4S. The idea for L4S is when there is a congestion in the network, there are feedback signals which are sent back to the application. And the application will reduce their throughput. Of course, this mechanism assumes that the applications are capable to adapt. And that's not the case for all the applications. In that case, there are other solutions which include, for instance, slicing and quality of service on demand. Here we want to make a reference to the work being done by the Camara project, which is trying to build the connection between the application and the network to access quality of service on demand, for instance. Now I want to hand over to Kevin from Ookla to provide his thoughts about the market trends and network requirements evolutions.
Thank you, Omar. Yes, Kevin Hazley, VP Strategic Initiatives here at Ookla. And if you don't know who Ookla is, you probably are very familiar with speedtest.net, running a performance test on your PC, mobile phone. So we are, I would say, authorities in understanding consumers' performance and the expectations of what networks should and are capable of doing, especially around the metaverse scenario. So what I wanted to do today was just talk about and put all that in context to what we published before around a gigabit city. We looked at Europe and really focused on, is it reality that today's market could be classified as a gigabit city? This is a perfect conjunction with what we're talking about today, is the speeds that Omar, Michael presented already. Is that reality of today's scenarios and today's fixed and mobile spaces? So a couple key points in this report that we created is we always had this ambition of a 1 gigabit city or 1 gigabit speeds. However, in reality, that's not possible today's technology, or possible delivering that type of speeds to consumers across many different factors and reasons. But today we're not seeing those speeds. So there is a gap between some of the expectations for what consumers are needing to be delivered for creating this metaverse application versus what they're getting today. Could it be their rate plans, their where they're placing Wi-Fi in the home, the type of application, the type of device that they're using? All those factor in. But we'll go through some exact speed reports and speed numbers to give you that aspect. Another key takeaway is medium download speeds and infrastructure development. So there's still a lot more investment that we need to make. And something that the World Broadband Association, as I am also a chair within that for the broadband advocacy work group, is that we're looking at the investments needed to be made to get the speeds up higher, to show where we're going and make sure that the investments are there to help support the needs of faster networks, lower latency networks, consistent networks. It's not about speed at times, as we just discovered. It's also about the latency. It's about the consistency to make sure when you are in a metaverse application, if anybody used it, put the headset on, you know that there is the one thing is the speed, but the consistency of that speed, the consistency of the latency over time is really going to change your perception of how well the metaverse is working. And if you come back and use it again, that's also really a key point here is we need to make sure when we're talking about the metaverse, it's an application that's constantly be using, not just for consumers, but for the pro level, the enterprises using headsets for emergency applications or flying drones to save people. I just read a news report about Colorado, and they're using drones to fly out to a lost child in the woods on this trail that you can't get to. So dropping supplies, you need a goggle headset and 5G connection just to make that work. And that's real life scenarios. So we need to make sure the investment's there. Also, altnets, something of using alternative network providers to play either the last mile or additional network capacity to make sure that some of these applications are doable. So that's another thing we took a look at. And then take-up rates remain a challenge, right? A lot of things that we talk about, especially in the Rural Broadband Association and in UCLA, is fiber. Fiber is really important. Fiber to the home, fiber to the premise. Fiber is really going to help bring that technology forward and make sure that that is consistent investment being made, not just with satellite, 5G, other technologies, but the technology of fiber as a base. So let's take a look at the on the road to 100 megabits at least and saying, where are we today? So a little breakdown of percentage of households. And I think this really complements what Michael was saying earlier. And this was produced by UCLA and DSI about percentage of households subscribing to fixed broadband, at least 100 megabits, or proportion of users achieving 100 megabits. So it is showing how many households subscribe, but the portion of users actually able to get that. And that's many, again, talking about the many different factors that contribute to why you can't achieve that highest end speeds. And it could be a device, it could be Wi-Fi scenarios, it could be the home, it could be, too far away from the base. There's a whole bunch of factors, but the study that we've created shows you the difference and shows you some of the key takeaways in there of what actually is achievable to if you're delivering 100 megabits, but the user cannot achieve that overall. And it really, if you take a look at the link in the slides that we send out, the broadband coverage in Europe, you'll start understanding all the data that contributes to that. And this is just looking at Europe for now, but there's other factors, UCLA's worldwide and global. And we'll get through some of those other areas as well outside EU. So talking about the reality of gigabit speed, here's another one in the same report. We try to break everything down so you really understand the percentage of households subscribing to fixed broadband of at least 1 gigabit. So that's the achievable one of, when we're talking about, Omar went through what's really needs of a speed and what we can achieve today. And one thing we got to keep in mind, it's not just about the speed, also it's about the bandwidth. So When you have a household with many different technologies running at the same time, video conferencing, cameras, my home is filled with just if you look at the Wi-Fi spread and the Wi-Fi being used, there's 20 devices online, 25 devices, and that's cameras, routers, consoles, TVs. So everybody's using that same speed coming into the home. So your bandwidth is getting lower and lower, being on the depicted device, and that's really true. So achieving 1 GB, you still have to make sure that you're utilizing whatever applications used for metaverse with that, again, that consistency. You get enough bandwidth coming into the home to allow each of those devices to share in that spectrum and the bandwidth to make sure the applications are working, especially, again, going back to the consumer experience. One thing you got to have is consistency to make sure that it's always being used and it's always ready. One more is the median download and upload disparities. We talked about this before, is what's the medium speed expectation and what's the download in that European market. So what we do from an Ookla standpoint, I talked a lot about speeds, but we use the median speeds. It's a standard metric for measuring performance. There's a story around the median speed being used for the end user experience, because you tie to median speed, you also tie it to the consistency mark. The better the median speed, the better from a consistency standpoint. If you look at anything else, you've got these tails of download capabilities that are outside the mark that removes that consistency, and you start going up and down in fluctuation as you use apps, as more and more devices get onto the network, you start losing that. So in a recent article, we highlighted persistence of legacy and underperforming Wi-Fi standards, for one, in homes, and it can hamper the efforts to provide the best network experience. That's the thing I've been consistently saying throughout this, as you see these slides, is that if it's the perfect world scenario of delivering a certain speed into the home, you have so many other factors that can inhibit it. That's why, there's Ookla's taking steps in toward helping address and fix the in-home experience, not just from a device standpoint, from all the devices, the Wi-Fi experience, the fiber experience, the fixed experience, and the fixed wireless access experience within the home, because there's so many factors that can ruin a good experience, and we need Ookla's trying to address that with our own speed test apps and consumer experience data and report and insights. I mentioned the role of altnets, which is also incredibly important because you need some alternative paths to get to the best experience. And here is a little chart here, just shows, again, we're talking about Europe only for now, but the number of active ISPs and fixed fiber to the home share of all connections. So the number of ISPs compared to the fiber to the premise share of all connections. So it really shows you from Portugal all the way up to Poland, there's some unexpected number here on the slide that shows there's a lot of ISPs that are trying to deliver that experience across Europe. So that's good. The higher the number, the better it is. The number of options there are for consumers of getting the best experience at home in Europe. And you can see this trend across many different countries, especially in the United States as well, when we have so many ISPs coming up, providing not only fiber to the home or fixed, but they're also taking that same technology and deploying 5G solutions on top of that as well, again, to extend the range and extend the connectivity that the consumer desperately needs to help address the Metaverse Standards Forum, and as well as a whole bunch of different applications. So something to keep in mind, I just want to say their future initiatives and investments, some things to take away is fiber offers superior internet speeds, lower latency, enhanced security, and environmental sustainability for purposes of Metaverse applications. So some of the upgrades that are happening right now is everybody's looking at the news us tech people are looking at the news and seeing some of the rip up of copper and replacing that. So a lot of good technology, a lot of good investments being made, but we need more. Altnets are making strides in driving fiber development across Europe as well as other countries as well, other regions, APAC, North America, and so forth, pushing towards a European Commission's ambitions of goals for achieving a gigabit society. So the more altnets are coming on board, the better likely it is that each region can achieve that gigabit city society. And despite progress, obstacles remain convincing consumers to fully transition to fiber services. It's expensive. There's a lot more technology, a lot more options for them to use for connectivity. So, but there's what we need to convince consumers is the services that is being delivered to them, the services that are coming down the pipe to them. We need to not only convince them that they're important, that they're value added, they're good services to use, but we also need ourselves to figure out how we can make the services better on other technologies beyond fiber. And that's something that I know a lot of companies like even Nokia is looking at ways of delivering across different types of technologies, as Omar described. So comprehending consumers' behavior, promoting fiber benefits, aspiring in initiatives will all play a significant role in this endeavor. So we're looking forward from a Worldwide Broadband Association as well as Ookla, the continued investments to make not only Europe, but also other regions on track to sustained connectivity targets. So I'm going to hand off to Marcus Brunner. Thank you.
Marcus, we can't hear you if you're on mute. Sorry, everyone, just bear with us 1 second. We seem to have lost one of our presenters. I know that sorry, I thought that was Marcus coming back. I know that we were in out of changing the order of things a little bit, but perhaps whilst we're waiting for Marcus to come back.
You hear me back?
I was just about to jump into some questions, Marcus, but now we can hear you, so I'll hand over the floor to you.
Okay, so I'm sorry, don't know what happens. Anyway, so since I'm the WBBA Working Group 1 chair, and the Working Group 1 is basically looking into the roadmap of broadband, and we basically have looked into the Metaverse application scenarios together with the Metaverse Standards Forum to look a bit more in detail at one particular application which might drive the roadmap towards 2030 and beyond. So that's the motivation why we have done that. You can see you can download the paper from the World Broadband Association webpage. And I think it's also available in one of the download features in the web at the moment. So we look now a little bit more into the future. You have seen sort of where we stand today. We try to look into the future. And based on the requirements we see from Metaverse and XR and so on, we basically have looked into one thing, which is sort of more the network requirement, what is needed in the network. And I show here a very simplified network picture to show you a little bit the requirements. There are several aspects we need to look into if we start deploying Metaverse at scale. And I'm starting from the left to the right. On the very left, it's sort of the home or enterprise network itself, not the operator network. There are issues we already heard about Wi-Fi and I'm going to talk about the Wi-Fi and fiber to the room a bit more, we need to look what does it mean if we go with XR and Metaverse towards future applications or even higher end applications in the Metaverse. The second one is naturally the access. We usually today have PON. New generations of passive optical networks are there. So we're currently we see the first deployments of 50G PON happening. Just was at the launch of that like 2 weeks ago. So this starts launching. We have enterprise scenarios where you have more OTN or fine-grained OTN type of application network technology, specifically needed if you need very good guarantees, very low latency and things like that in an enterprise space. The other thing, Omar was already mentioning it, you see in that picture at several places, it says compute functionality or cloud data center. So we need to discuss where the cloud and the computing is going to happen. So this can happen at various places. And in the picture here, we basically see that it can happen at any of those places, depending on the deployment and depending on the applications, various places can be chosen. So that's sort of the very big picture on the sort of an architecture for a network to support the metaverse at scale. Now, let me move to a few aspects of it in a bit more detail. The first one is the home and SME networks for delivering the metaverse. I put up the chart here for the different Wi-Fi generations. And what you see is the maximum theoretical speed per Wi-Fi generation. We are currently at the Wi-Fi 7, so that's currently deploying. So you see there is from 1.3 to 40 gigabit per second. So basically the Wi-Fi as such is there. What that also means, you need to look at the backhauling of this Wi-Fi access points. Specifically, you need to look at the backhauling of the Wi-Fi if you move to a Wi-Fi 8, which is expected to be somewhere in the 100 gig theoretical speeds. Naturally, you only get this theoretical speeds on a very short range within a room or something like that. So that's the reason why the right chart is basically showing and the expectation showing of fiber to the room deployments. We see that fiber to the room is picking up speeds. There are deployments specifically in Asia at the moment, massive deployments already going on, the rest of the world picking up. So as soon as you have very high speed Wi-Fi, you also need to have fiber to the room to have backhauling that Wi-Fi. And then naturally, if you go 50G PON, you also need to show this higher speeds, like we talk about now 10 gig to the home. Basically, you want to distribute that 10 gig in the home as well. So you need to look into the home and SME networks on the customer premises side. So these are one particular aspect we need to look into more detail into it. On the access network, it was already touched upon that fiber to the home connections have basically crossed the number of DSL connections already 2015. That's already 10 years ago. So the fiber deployments keeps on going. There is more fiber deployed, but many countries these days have a very large fiber coverage already. So it's relatively easy to upgrade this fiber plant, the passive fiber infrastructure, with more active equipment to come to higher speeds for all types of different metaverse applications. So that just shows that the access network as such is improving. Several generations of PON technology is available. The latest 50G PON generation is deploying now. So now to come to a conclusion, that's sort of the last table we have put together in that report we did. That's basically, we use the metaverse applications roadmap. And that's you need to understand that that's a very rough estimate. We can discuss some of that numbers. Think of it as a rough estimate. And you heard Omar saying that today, with today's technologies, we are already able to do some metaverse applications. That's what we would call the entry-level XR. So basically, this is possible to do today. In Broadband Forum, we call this the Broadband 5 generation. That's sort of going up to the gigabit broadband speeds, having fiber to the home, fiber to the room, plus Wi-Fi 7, having very high reliability and low latency for the access in that case. And we have autonomous network level number 3 that have more automation, but not fully automated yet. So then the second level is where we have the advanced XR. It's basically where we look into video resolution more in the 12K space, where then you need have download speed somewhere in the 300 to 500 meg per stream, 10 millisecond latency. And this comes basically because you have much more interactive type of services. You have cloud-oriented virtual reality applications. So that's what sort of would correspond to the World Broadband Association roadmap, BB 5.5, where we are targeting 10 gigabit broadband. Enterprise space, even higher broadband, but that's not that of that interest here. There we also talk about the Wi-Fi 7/Wi-Fi 8. One time we move over to that. Even lower latencies are possible because advanced XR need even lower latency because it's more interactive. And so lower latency are needed. And then the projection towards the 2030 plus years is the ultimate XR. So this is the seamless human experience. We believe that this is somewhere in the 24K resolution space. That's where you start going into the 1 gig and 5 millisecond per stream space. That's a futuristic space. For the broadband generation, this would correspond to the Broadband 6. And there are a lot of open aspects for that. That's sort of unclear at the moment from the technology perspective, how much optical you go to the room, to the machines, and so on. Use of fiber sensing capabilities, for sure, Wi-Fi 8, being more deterministic and being fully automated. So that's sort of the roadmap, trying to bring the metaverse applications roadmap and map it and match it to the WBBA, the World Broadband Association, Broadband Network generational roadmap. So this is what I had to say from my side. And with that, I hand back to Michael.
Thank you, Marcus. And thank you to all the presenters today. And we're now going to move into our Q&A part of the webinar. So I'd just like to remind everyone that if you wish to submit a question, you can do so through the Q&A widget. We've already received some questions as the speakers have been going, but please feel free to add more questions. We've got about 15 minutes, so we've got plenty of time to answer questions if you have them. I'll just move on. So we had some questions coming in whilst you're all speaking. So some of these are just for clarification, I think. So I'll just run through these. There's one for yourself, Kevin. Do you think the speed limitations on the link speed reality is the incumbent NICS of the 100 megabits per second in the infrastructure? Is that the bigger issue, or is the nick in the consumer device that's the problem? I think that I'm trying to. I think that's what that question's asking is the issue in the actual network, or is it actually devices that are not capable of kind of handling that speed? I think that's what they're getting at there.
Yeah, that's a great question. I think the easiest answer is to say both, but in majority of cases that we have seen, it's in the infrastructure side, not the device side. So we've seen a plethora of number of devices connecting via different aspects using our speedtest.net. majority is connected via wireless or some other proxy, most on mobile devices. But if you look at the holistic view of all data coming in and the limitations, it's mostly on the infrastructure side.
Great, thank you. Omar, I think Marcus kind of answered this question, but for just completeness, there's a question here for yourself. Are the download and upload throughput requirements of 80 down and 30 up, as in for the most demanding applications, based on today's requirements or yours projected, for example, out to 2030?
This is based on today's requirements, and those are for most demanding application, 30 downstream on the downlink and 10 on the uplink can satisfy a lot of applications already. But those are today's assumptions. Moving in the future, it will depend on, for instance, Marcus said about the codecs, and codecs evolution may reduce the bit rate, but if we move into high definition 4K, 8K, 12K, of course, it will increase the requirement in terms of throughput. Yeah.
I think this question is going to be very difficult. I know, Marcus, you give your view as to 2030 plus, but there's a question here about moving out even longer. So speeds in 20 years, due to XR and Metaverse, what do we think the projected average broadband speed might be then? Have we got any opinion on that from anyone on the panel?
Yeah, it's like, I think 20 years is really a little bit too much to project. I would assume already 10 years. I mean, look back 10 years from now and where we were. I mean, what speeds did we have? What applications we had? What networks we had? So I think like more than 5-10 years to project is very difficult. But my assumption is I'm now long enough in the industry, and I see a growth of the speed needs over time through different applications, even more devices. Kevin was mentioning all the different cameras he's running in his house. If you start having more AI in the background, you need to transport all the data to this AI compute clusters and crunch those numbers. So you're going to have even higher bandwidth needs in general. So I believe the bandwidth needs in the future are going to increase and increase. I know there are certain people which believe different, but my personal belief is it's going to be increasing in a similar rate as we have seen it over the last 10, 20 years. I don't see why not. Specifically, if you look into this metaverse applications, and I've seen another question, probably I answered that right away. There was a question on what FTTM means in FTTT. FTTM means fiber to the machine, and FTTT, fiber to the thing. We do experimentation in fiber to the machine. If you have industrial applications, you cannot have codecs to basically reduce the bandwidth because you don't have the time to reduce that bandwidth. So if this is needed, have extreme low latency, having an AI behind to make a fast decision on certain things, like in the home, is something wrong in your home, you need this bandwidth. So I don't see why that should change.
I will add something to what Marcus says. I agree. I also think we're going to look at measurements in a different way in the future. 20 years can't project, but coming up for 5 to 10 years, the change over looking at just what we talked about here is the consistency, the latency, the reliability. Those are going to become extremely important when we have more and more devices. And even some of us in our homes in the next 10 years, whatever it is, has AI engines, AI robots, all those things that we talk about in futuristic terms. We talked about that in the past, and all of a sudden it became reality in today's world. So I think there's going to be a lot more things, the machines that Marcus talked about, that's going to have a always on connection that's always streaming at a certain capability. So we always have that consistency and reliability. It's not necessarily about the speed in parts of the some of the applications that we look at.
Okay, great. Thank you. Amar, I'm not sure if this is something that the MSF has kind of looked into and explored, but I'm hoping that you might be able to provide an opinion. They've asked, what is your opinion on the killer app that will fire the Metaverse and XR, and when? Is that something that you have looked into?
Well, we see a lot of traction in the industrial metaverse domain because the use cases that people are looking at can provide an immediate return on investments related to the digital twins. If you want to reprogram a factory or reconfigure your factory, there are very, very concrete and immediate use cases. For the consumer space, it's starting from the gaming industry and moving to other applications. I'm probably not the best expert to speak on this because I'm coming to the metaverse from the network side, but we rely on other people to tell us the applications. So,
yeah, understood. I mean, certainly from our side, we also see gaming as being the obvious driver in the consumer space, followed by entertainment. We did have originally we were looking to get a spokesperson from the BBC, and they were going to talk about how they're using XR technology to develop new experiences, specifically around music entertainment. So we're certainly seeing an interest there. It is very much in the early days, and as I said in my presentation, I think we'll need both the devices to become more affordable, but also those use cases to be, more attractive content that's going to capture consumers' interest. It's a bit of a chicken and egg thing, but we do see that's starting to happen 2024 onwards. So that's certainly our take on things. There's a question here, I guess, either for Kevin or, well, for the panel in general, really. Do you think the broadband speed development would be driven by service providers or by the consumers? I can give an analyst view as well, if you like, but I don't know, Marcus, from a vendor's point of view, what's your view on that?
Yeah, at the end of the day, it needs to be driven by the consumer. The problem is that is like the deployments take a long time. You need to project quite early on what you need, and it's many times also driven by competition. So depending on the markets, competition is driving it. And finally, there are certain countries where regulations is driving it. So policies and regulations we didn't touch upon that here, but I mean, for example, where I'm living here is 80 megabit is the absolute minimum you have to offer. Everybody has to offer that. So it's the minimum speeds. So it's like the regulatory minimum is given. So this is driving certain levels of increasing the speeds and then improving the infrastructure as well.
And I'll just add to that, exactly right. From the regulator standpoint, the policies, we again in the U.S. there's FCC guidelines 120. However, I just want to go back to the point about the consistency and reliability aspects and latency. Yes, the speed will be developed by the ISPs and providers. Look at 5G. Consumers weren't asking for 5G necessarily. They were asking for 4G to make it more reliable. Make sure I can do what I need to do with this technology wherever I go. And so that's going to be the consistent conversation that consumers have is, I need it more reliable. That's the complaint that we hear from Ookla, from our consumers that run the speed tests. Reliability is key, consistency. It's not necessary, I need a faster connection. So, but I think the applications that we adopt, going back to several other questions, is what's the killer app? What's the application? The applications come on board is going to be driving some of the speeds as well, the adoption of the needs of 5G and the uptake on the policy to change the speeds. It's also going to be about the bandwidth within that speed, as how many devices can connect at the same time. Marcus talked about the Wi-Fi 7. bringing those type of technologies where more and more devices can come in is going to be key.
Great, thank you. Omar, there's a couple of kind of very similar questions. So I'm going to kind of try and summarize and hope that it answers both these questions. But this question kind of around, the ability of the network to provide XR and metaverse applications in a kind of a consistent way. Is that holding back the kind of device vendors and application developers to create these more affordable devices or more attractive content? Do you see that in your area?
Well, from at least from the MSF perspective, the technology is very capable today of supporting several of the use cases those developers or those device vendors are looking for. Some of the issue we have seen is, especially when considering those data sets from Ookla, is deploying the right feature sets and optimizing the network for metaverse traffic would be needed. But it may call, and at the end of the day, if we don't create these interactions between the applications and the devices on one side and the network on the other side, it could be a challenge. It could be a challenge because you would typically end up relying on a best effort network with inconsistent user experience. Of course, this is a difficult and important endeavor because it may have ramification into business models and business model evolutions. And if, for instance, slicing is extremely important, it could unlock several of the metaverse application, but the operators and the application providers needs to find a way how they configure the slice and how to commercialize it, for instance.
Okay, great, thank you. So there's two kind of similar questions there. So I do hope that answers both your questions. But if not, then please get back in touch if one of you thinks that we haven't answered it properly there. There's a question also on explanation of 50G PON. Marcus, but I would suggest in the interest of time that we get back to them in writing on that one. And then Kevin, just I think one more question for you is around what regions are advanced enough in connectivity are more likely to be able to support metaverse type applications?
Yeah, according to our Speed Test Global Index, I think the ones that everybody should know is Singapore. If I look down and scroll down the list, Singapore is really up there in speeds and latency improvements. UAE, Hong Kong, Chile, United States, France. Those are the countries that has a median speed across the nation that actually can support some of the metaverse applications, as we talked about with Omar and the speed capabilities. I just want to give one quick example of what is a region that cannot support it. So I'll just give you really quickly in our latest results from Cuba. I know that doesn't come up as a region that's okay. Cuba, we're going to launch metaverse standards, metaverse applications. However, their median download speeds is 2.84 megabits on fixed and under 1 for upload, and latency is 113. So you look at the reality of all these, they're ranked 158th of all the countries. But if you look, there are regions that will not support metaverse applications across the nation. And so it's important, as I keep on reiterating, about the consistency and to make sure everyone can actually get the applications. So when we talk about what's holding us back of getting the metaverse out so everybody's going to use it, it's that consistency that every single user has the same type of experience, which is going to be great across the nation, so we can get more and more people involved and more people using the technology.
Thank you, Kevin. So that kind of means that we're pretty much out of time. If we haven't got round to your question, there are a couple of questions still in there. We will try and get back to you via email. But with that, it just leaves me to thank all the panelists for their time and their participation today. I'd obviously like to thank everyone also for attending the webinar. I hope it's really been valuable and a lot of good information there for you. An archived version of this webinar will be available shortly, so feel free to come back and view this session again or share it with your colleagues. Thank you very much.